Okay, welcome back. So back onto our reciprocal trig functions, and what we're just going to look at is just dealing with some of these things. So in the last video I quickly talked about it, but I didn't really do it. But let's just revisit. So we've got our sec x, and remember that means 1 over cos x. Okay. Cosec x is 1 over sine x, and cot x equals 1 over tan x. And remembering that tan x is sine over cos, and so if you've 1 over tan x, what you're going to get is cos over sine. Okay, so they're important to know. And so if you have a triangle, you have some angle x there, and so if you remember that obviously sine x, and so we've got opposite, hypotenuse and adjacent. Sine x is equal to opposite over hypotenuse. Okay, so therefore cosec x is equal to this upside down, and so it's hypotenuse over our opposite side. And so that's a quick way of being able to find cosec, is just O over h. Similarly, cos x is equal to adjacent over hypotenuse, which implies that sec x is equal to this upside down, which is h over a. And lastly, tan x is equal to adjacent, what am I doing? I'm not doing very well this video. Is equal to opposite over adjacent. I'm thinking ahead. Then cot x is that upside down, which is a over o. Okay, so there you sort of your 6 ratios of every triangle. Okay, so we used to think it was 3, but now I've introduced these other 3, and that is absolute. That's the most possible different ratios you can get in a triangle. There's 6, and there's all of them. And so we can use all of those. Now, at this point in time, I introduced back in, I think it was in circles and things like that, it was parametric equations. We know that there's this identity sine squared x plus cos squared x equals 1. This holds for all x. And I showed in that quick video quickly that there's 2 other identities that also work. So 1 plus cot squared x equal to cosec squared x, and also 1 plus tan squared x equals sec squared x. So these are also 3 identities that we can use in any sort of situation. And just a little note down here before I sort of launch into some examples. Some people get confused as to not knowing what sine squared x means. Does that mean, is that sine x squared? Is it, x squared or something? What is it? No, it's not that. Sine squared x is just a short way of saying sine x all squared. Instead of writing that, we just put the square on the inside. It just looks nicer, it feels cooler, and we math snobs feel like it's fun. So make sure you know that that's what that means there. Okay, and what we'll do is we'll get into some examples. Okay, so let's do it. Firstly, maybe let's just simplify something. And these are always fun. I find them fun. Students tend to hate them, so sorry about that. Here we go. If you could please simplify cot squared x minus cosec squared x. Okay, let's simplify this. And when you're asked to simplify something, I would just write it out the best that you know how, and then and try to get them all as sines or all as coses or all of the same sort of function, and then hopefully it'll sort itself out. Okay, so firstly, cot squared x. Cot is, what was cot again? Well, tan is sine over cos, so cot is cos over sine. Okay, and because it's cot squared x, would be cos squared x over sine squared x. So there's your cot squared x. Okay, now cosec, it looks like cos, but it's not, so it's 1 over sine. 1 over sine squared x, and so it simplifies to that. And look at that, you've got the same denominator, so they go together really easily. So let's do that. sine squared x on the bottom, and then you have cos squared x minus 1. Now at this point you go, alright, what the heck do I do next? Well, we either want to make, I'll show you what I mean. We want to make these the same. It's hard to deal with a function that has a cos and a sine. So we want to either change the sine to a cos, or change this cos to a sine. Either way, we want to make them so that they're the same. Okay, it's up to you. It doesn't matter which way you go. I'm going to look at this and go, well, I can sort of see what's going to happen. I'm going to change this cos x into sine x. Okay, so just remembering that cos squared x plus sine squared x is equal to 1. Just remembering that, what will this top line be equal to? Well, cos squared x will be equal to 1 minus sine squared x. Okay, so that's cos squared x, that's just that there, and then we've got the minus 1 over sine squared x, which is, we're going to have 1 minus 1, so they'll just disappear, so you can have negative sine squared x on the top line. Bottom line, you're going to have the sine squared x. You're going to get some cancelling, that cancels, and we get negative 1. And so that's just a case of looking at something that's horrible like this. You'll get this from time to time, and you go, that doesn't look very usable, but in fact it's just equal to negative 1. So put them, simplify them, or expand them, as you might say. Expand them out, try to write them as a sine or a cos. Either way, you could have done this, write this sine squared x as a 1 minus cos squared x, and then factor out a negative 1, and you'd get the cancellation, top line, bottom line. Okay, so let's just do a different type of example. If you get these all the time, if tan x is equal to negative, let's just do 4, tan x is negative 4, and x is in the range from negative pi on to 0, then find, okay, that's as a find, not find. Find sec x, find cos x, and just for the hell of it, find cosec x as well. Okay, so let's do that. Firstly, how to find sec x. Okay, so part A, I'll do it all anyway, just for fun. It looks nicer. Sec x, what have we got that links sec x to tan x? Well, in fact, we've got this identity that I just talked about. 1 plus tan squared x equals sec squared x. Fantastic. So we can link here. So therefore, sec squared x will be equal to 1 plus tan x squared. And so that'll be, so instead of tan x, we're going to have negative 4 squared, because tan x was equal to negative 4, so that's just negative 4 squared, equals 1 plus 16, which is 17. Okay, therefore sec x is equal to the square root of 17. But it's actually the plus or minus, isn't it? Because when every time you take a square root, you need to take the plus or minus. But let's just have a look at what quadrant we're in. We're in negative pi on 2 to 0, so we're in that quadrant there. And so let's think about, will sec x be positive or negative in that quadrant? Well, sec x, remember, is just 1 over cos x, and cos x is positive in this quadrant, and so therefore sec x will be positive in this quadrant. Okay, so therefore it's equal to just root 17. Okay, so just make sure this will always throw up two different values because you're always taking square roots. Just make sure you choose the correct one for the quadrant you're talking about. Okay, part B, we want to find cos x. Couldn't be easier. Cos x is 1 over sec x. It's just the reciprocal, and so that is just 1 over root 17. Okay, again, cos x is positive in this quadrant, just like sec x is. Okay, and if you want to write that in its proper form, root 17 over 17 with that not having a set on the bottom line. Okay, finally, C, we want to find cosec x. So what have we got that relates cosec to anything? At the moment, all we really know is the identity 1 plus cot squared x equals cosec squared x. Okay, so do we know cot? cot x? Well, we don't know cot x, but we do know tan x. Okay, and so therefore, I'll just let's just do this. I'm just going to go for it. Okay, so therefore, cosec squared x is equal to 1 plus. Now it's going to be something squared, and it's going to be cot squared. We don't know cot, but we know tan, and that's just the reciprocal of this. Okay, so just remembering that's reciprocal, so it'll be 1 over negative 4 all squared. Okay, right, so that's equal to, this is 1/4 squared, so that's 1/16, so it's going to be 1 plus 1/16, and so 1 plus 1, so that's going to be 17/16. Okay, beautiful. Just let me check that. I feel like I've made a mistake. 1 squared 1/16. No, that's right, 17/16. Okay, so therefore we found our cosec squared x. Therefore cosec x is equal to the square root of 17/16, but plus or minus. Now in this quadrant, let's have a think about this same quadrant. Now cosec is 1 over sine. In this quadrant, sine is negative, and so therefore cosec will also be negative. Okay, so that's equal to negative root 17 over 4, just simplifying that, root 16 on the bottom line. So there is your cosec. So there's your 3 answers, and that's sort of how you work out those. Have fun.